Hi, Professor. This is Julia Schneider from Survey of Calculus Math 130, and this is my 5th video correction. This video is concerning learning objective A1, which states I can use derivatives and other information to make informed sketches of the graph of a function. What I should have done is taken all these clauses and labeled what they all meant. I did this one, and that's about it. Which I should have let then inform my graph, but hence this embarrassing note. I did not do that. I was in shambles during the test. So let's get into the video correction. At first, I will be correcting this same example, and then I will be providing 2 additional examples. So yes, let's get into it. So the first clause that it says, g prime of 2 equals 0 and g prime of negative 1 equals 0, means that at x equals 2 and at x equals negative 1, there are critical points, and they are either maximums or minimums, and we don't know what they are yet. All we know is that they're critical points, and that they're either max or mins because it's the first derivative, and it equals 0. So, yeah. So the second clause states that g prime of x is positive in the intervals negative infinity to negative 1 and from 2 to infinity. And this means that g of x is increasing from negative infinity to negative 1 and also from 2 to infinity. And then the third clause states that g double prime of 2 is greater than 0, and that means it's concave up. We know this because the second derivative of the function gives you concavity, and it's greater than 0, so we know it's concave up. And then the fourth clause states that g double prime of 0.5 equals 0, which means that at x equals negative 1, there is another critical point, but it this time is a point of inflection. And all of these clauses are satisfied and depicted here in this graph, where you can see your point of inflection at x equals negative 1/2. Sorry, this should say x and y. And you see your maximum at x equals negative 1 and your minimum at x equals 2. And you know that that is the case because of the concavity. It goes from being concave down to concave up, and everything is satisfied. All of the critical points are labeled here. So now that this is corrected, let's get into the 2 additional corrections that I have prepared. So this next example states that f prime of negative 3 equals 0 and f prime of 4 equals 0, and this basically means that x equals negative 3 and x equals negative 4, those points are maximums or minimums, just like the previous example. It's kind of, the same for every example, but yeah. And then, not the same, but you get what I'm saying. And then f prime of x is negative in the intervals negative infinity to negative 3 and from 4 to positive infinity. And as I labeled, this just means that there is a negative slope in the original function. And then the third clause states that f double prime of 4 is less than 0, which means that it is concave down because this is the second derivative, and yeah. We know it is a maximum because it's concave down at x equals 4. And we know that it's this shape because this is less than 0. And then it also states that f double prime of 0.5 is 0. This means that there's a point of inflection, again, at x equals 1/2. All of these clauses are depicted here, where, here we go. You can see all of the critical points clearly labeled. X equals 4, there's a maximum. X equals negative 3, there's a minimum. And at x equals 1/2, there's a point of inflection where it changes from being concave up to concave down. And yep, everything is satisfied and depicted here. So the next example, example 3, states in clause 1 that f prime of -1 equals 0, and at f prime of 3 is also 0. And this basically means the same thing, that x equals 3 and at x equals -1, these are either max or mins. And the second clause states that f double prime of -1 equals 0 and f double prime of 1 equals 0. And this means that at x equals -1 and 1, these are points of inflection, so these are all critical points. And then the third clause states that f prime of x is less than 0 on the intervals 3 to positive infinity. And then that f double prime of x is greater than 0 on the intervals -1 to 1. And that also tells you that it's concave. Well, it's concave up here, and then you can have an informed guess of, you know where it's concave down, everywhere it's not concave up. So, yeah. And then you know that your slope is negative on these intervals and positive on these other intervals. And all of this is represented here. We have our critical points. At x equals 3, there's max, and then at x equals -1, there is a minimum. Oh, wait. No, there's not a minimum. There's just a maximum, and then these two are points of inflection, which is very interesting. And yeah, super interesting. I hope this suffices. Thank you very much for watching.